Hello everyone. So today I'm going to uh, provide solution for a weekly contest 365. So let's go to the first question. Uh, okay, so the first question and second question is same, but the constraint is the difference is in the constraint. So we will directly solve the second question without going to the first question. And so in the first question, you can see that the num length will be 100 order, and uh, in the second question is it 10 power 5. So here you can apply the brute force. You can select the I, J, K indexes and then solve. So I'm going to solve second question, and then you can submit that one in the first. So what I'm going, if you read the question first, then you can see that he's asking this we have to maximize this value. Okay, so how can we maximize this value? So the j should be something here, and I should be from here, and k should be from here. Okay, so I is less than j and j is less than k. So if we want to maximize this, okay, so we want to maximize this, then the I nums I, okay, so we can call it ai. So ai should be maximum. Okay, and this one also should be matched. AK should also be matched. Okay, and what about j? Then we can say that j should be minimum, but we cannot guess directly, so we are going to iterate over j. So the solution will be simply iterate over j, iterate over j. Okay, so for all j we will find the maximum on this side. Okay, and the maximum this side, and this is j. Maximum left side, maximum right side. So the answer will be simply max left minus a of j into max right. Okay, so this we will take all maximum of over all possible j, and that will be our answer. So the question is pretty simple, I guess, if you got the idea. So what I have done, I have simply first make the suffix of maximum. So we name it SMA, means suffix of maximum, and then this suffix simply uh, will store the maximum up to I to n minus 1. Then I am this MA will store prefix maximum. So we no need to create an array and then store. We will simply iterate, and then we will store that value. Okay. So this loop is for j. Okay. So for each j, what we are doing, we are simply taking the maximum of previous answer and the new answer. Okay. So what is the new answer? New answer will be the left side maximum minus ai into right side maximum, that I have already told. Okay. So and then this I am updating the left side maximum as a maximum current, and then new ai we have written. So and finally the we are returning. So the question is pretty simple, and implementation is straightforward. So after this, I'm going to move to third question. Okay. So in the third question, what is the like question is saying that you will be given zero index array and a target value. You have to find that this target can be made from the array, concatenation of array. So let's give me example. Like if we have array of 1, 2, and 3. So what we can make it as long as possible, like 1, 2, 3, then 1, 2, 3, then 1, 2, 3, like this. We can make up to whatever length we want. Okay. Now in this big array, you have to find that what is the minimum length of subarray, the shortest subarray that will sum up to target. Okay. So let's say from here to here, we got the minimum length. Okay, so if you are going to do the brute force like appending the subarray and then finding that we cannot do. We cannot do that. So what will be the logic? The logic will be, first of all, look at like this. Okay, so whatever the subarray you will take, okay, whatever subarray you take from, let's say, I to J you are taking, then if its length is greater than some kind of 2n, yeah, if its length is greater than n, let's say I to J, its length is greater than n is the length of array. So if its length is greater than n, then what will happen? We have some kind of suffix this side, we have some kind of prefix of array this side, and then we have this side some whole array because the length is greater than. So one array must be there. Even it might be possible that you are not taking the whole array. This side and this side will become sum up to n. Okay, so I'm taking that length is greater than n, not equals to. So in that case, there must be one complete array. Okay, so uh, will this complete array. Okay, so this complete array going to form. Now we can ignore this array and subtract this sum already from T. So that will be logic. Like let's say there is a big length I to J, and there are many complete array. Okay. So this. So we can already subtract these array. We don't need to do at that time. Okay. So only we have some kind of suffix, like this will be complete subarray, and we have taken sum of the element. Okay, and this will be some suffix and this will be some prefix. Uh, like from here to here, this is complete array, and we have taken only up to this. So the logic will be like only remove all the whole sum, only take suffix and prefix one. Okay. So how to implement this? So simply just find the sum of the whole array. Okay, so here I am doing finding the sum of the whole array, and then after that here I am doing I am just counting how many subarray I need. So not subarray, how many the whole array I am needing. Okay, so this will be n into ty sum, and then here I'm making that target as a modulo sum. It means the only remainder will remain, and all other things that complete subarray will have, that will be reduced. Okay. So the count will store how many the whole array we need. Now the target will reduce to remainder only, and it will kind of prefix plus suffix, not the whole array. So how are you going to deal with the prefix and suffix? So that is the now question reduced to how you are going to deal with the this suffix and prefix. So you can think like this. Okay, so we have kind of array, this array, and we want some suffix and we want some prefix. Okay, but if you are going to do like this, taking all the prefix and checking all the suffix, that will be not optimal. So what I have done, you can choose other approach from there. So question reduced to like choosing some prefix and choosing some suffix that sum up to target T, and target T is the remainder now. Okay, it is not possible that the whole subarray going to sum up to T. So prefix and suffix, how you are going to take, that will be your choice. But what I have done, I have appended the again this array. So this array, like the array and then array. Okay. So now if we want to take something, then we are going to take any subarray. So why we are going to take any subarray? So this prefix we can find here, and this will form a subarray. So this is the logic I am applying. So what I am doing, I will take any subarray of this two combined array, and then check that sum up to t or not, and we will going to take the minimum length. Okay. So this is the famous question that you are given an array and you have to find that minimum subarray that is sum up to t. Okay, so we can do it with the map. You can take your own approach. So what I'm doing, I will store the prefix in the map. So here I'm storing the index of that, and then we are like how we are going to update the minimum length. Minimum length will be minimum of previous length, and then the new length we are going to find. So new length will be position of p minus t. So let's say here p minus t, and we are at I minus 1, we are going to find the p minus t, and then here we are, it is, let's say, some index j. Okay, or we can say some index, any kind of index. So j minus 1, and from j to I we are going to sum up to t. Okay, how? Because here it is p, and we are finding the p minus t index. So if we subtract p minus t, then it's going to t. Okay, so this will be our t length, t sum subarray. Okay, so that's why I'm updating like this. If you are not understanding directly, then you can uh, like think, you can check with one example, then you will get the understanding. So I guess so taking the answer temp as the minimum, and temp is in slide with 2n plus 1. So if it is still 2n plus 1, then we are not going to find any answer. Okay, so we are not able to find uh, any summary that sum up to t. Okay, so in that case we are returning 1. Otherwise we are simply returning temp plus count. Count is the initial total. Okay, so count is like how many whole subarray is there. So that's solve our problem. So let's move to the fourth problem. Okay, so here the fourth problem is pretty straightforward. I guess if someone has practiced this kind of question, then they can solve very easily. So what I'm going, how I have solved, I'm not. There might be other approach also, but how I have solved. So let's say there are many other nodes. Okay, 4 like this, not like this, 4, and then 5, and then 6 like this. Okay. So I'm going to do like, first I will find this. First I am going to find the length of this circle. If you okay, so let me read the question if someone has not written the question. So the question is simply like you are given n edges, not edges, n length array. Okay, so let's say this is the E array. So what will be the E of I? E of I indicate that there is S between, not between, from I to A of E of I, E of I. So they are kind of this kind of is. Okay, so the graph is directed. Okay, so you can see there are n edges, so there must be a cycle. It is not possible that uh, you are not going to find this. Okay, so from any vertex, if you started, then you are going to end up into some cycle, because the proof can be done like this. Okay, so you, let's say you are started at I. Now you go to J, then K, then like this, you keep on going. Okay, let's say you are at index something, some index in. Okay, now let's say you are end up here, but this cannot be possible because there must be one edges, because the length of the edges array is n. So every vertex has one outgoing edge. So there must be some other edges. So at max n you can visit, then again you are going to end up some kind of already visited vertex. So there from anywhere you started, you are going to end up in some cycle. So that is the question. And now we have to find that from any vertex, if you have started, then what is the number of different vertex you are going to visit. Okay. So, uh, so number of different vertex is simply like uh, at the end you are going to end up in some cycle. So the cycle length plus how many this non-cycle vertex you have covered. Okay. So that is the final answer. So why I'm separating this cycle other than and separating this one. So the logic is like if you are mixing both of them, they are going to get the wrong answer because sometimes you have started from like this 4 and then some 5. So let's say you already calculated this 5 or 4. If you are already have visited this 5, then you are going to calculate the 4, then 3, then 0, then 1, then 2. Okay, so the 4 answer will be correct and then 5 answer will be correct. Okay, so it will be 4 and 5, it will be 6, it will be 4, and all these will be 3, 3. But let's say first you have calculated this. Now you are going to do like this. Okay, you are starting from here. Let's say you are starting from here. Now the problem is that if you start from here, you will ask that how many length 3 will have because it already calculated. So it will have 3 length and you will do 3 plus 1 because you are at 1. Okay, but this is wrong because the whole cycle is 3 length. Okay. So these kind of ambiguity can arise if you are considering the cycle plus these kind of thing altogether. So that's why I am separating this kind of thing. So first we will calculating the length of cycle, and then this kind of thing can be done with the DP. Okay. So this kind of thing I am going to do with the DP, and the cycle kind of thing I am going to calculate the separate. Okay. So how I am going to do? I haven't prepared any graph kind of thing. So I am just uh, iterating all the indexes, and if it is 0, what is mean by 0? It is not visited till now. Okay. So if it is not visited, then I am going to visit each and visit this vertex and then move to the next one. So at the end, if already all the things are visited, then we are going to end up somewhere that have either -1 visited value or that has already been visited. So -1 means we have already in some previous, like let's say for I, we are going to some j, then k, then like this, we are going to get the this. So for this case, the visited j will be 1. Okay, visited j will be 1 because we are in this only we are making it 1. But it may be possible that in the previous somewhere we have already done that. We are end up somewhere like this KL. Okay, so the visited L might be in the previous I -1. It is already indexed to L. So we have already calculated the value of L. We need not to go to L. Okay, so the circle from L or after L, that will be already calculated. So no need to calculate from I. That's why I am checking. I am making the visited here. I am making all the visited as -1. And if it is -1, then no need to do anything. Just continue. Okay. So just continue. And if it is some kind of new circle, we are going to get a new circle. How we are going to get? We end up from here. Okay, so visited is 1. So now in that case, we are calculating the length of cycle. So I am making that as a 2 visited of 2 and then calculating the count plus length of the cycle. This will calculate the length of the cycle. And then after that, after calculating the length of cycle, we are updating all the DPs of the cycle. So like this, if all the nodes that are in cycle, we are updating with the count. Okay. So after that, everything is done. What we are doing? We are making every node that is the part of the cycle, or that is not only part, that is from I, J, K, all these from again we have started and going like this, go like this and then come back again. Yeah. And making is the -1. Why -1? Because in the next step we are not going to do anything related to with this, because again and again you will get theory.
That's why I am making the -1. And after making -1, the all the cycle DP are visited. All the cycle DP are calculated. Now only the non-cyclic DP will be remain. Okay, so how for each I am how going to I am calculate the answer. So I will call the DFS IDPE. So how DFS will work? It will simply check that if DP is already calculated, then return. So if it is not calculated, when DP will be already calculated, when it is part of some kind of cycle. And if it is not calculated, then we are going to calculate as a we will call that next to next EI means next vertex and then DPE and +1. So this will calculate our whole answer, and we are storing that on. So let's say for example I'm going to do with this one. So how, because the question is little bit uh, mine implementation little bit other than, so I'm going to explain with the example how I'm going to. So let's take other one also, and not this like this. I'm going to take some kind of, I'm making little bit uh other than this. So let's say not like this. 5, 3, 1, and then 0. Then here we can take 4. Okay, so in this, how I'm going to do? So first I will from 1 I will start. From 0 I will start. So from 0 we will mark it as a 1, then mark it as a 1, then mark it as a 1, then 1, then 1. Okay. Now here this while loop calculate. This while loop will terminate. Okay. So here our this while loop will terminate at 5 because we have marked as a 5. And no visited -1 is found, so we will not this if will not executed. Now again coming to here, if you look at here, what I'm doing to mark all the cycle node as count the number of node in the cycle. So from 5 we will start again and the complete this circle, and then count will be 3, and all these node will be marked as a 2. Okay. So now all the node as a mark as a 2. Now what we are doing, update the DPs of the cycle. So with the count. So all these node will updated as a listed as a 3, and each DP will be DP of all the cycle node will be 3. Cycle node I'm saying. So this is the like finally, and then last what I am doing here, what I'm doing, making all these node as a -1, because in the next step it should not be calculated. So I will make this as a -1, this as a -1, this as a -1, this as a -1, and this also as a -1. So now when we will move to one, again from 1 we will start. So here no while loop will be executed because no b state is 0 and b state is -1. Then we simply continue because we are mark is the -1. For similarly for 2, 3, and then coming to 4. Now what will happen at 4? 4 is not visited. So we will this while loop will be executed, and we will end up here, okay, at 0, because 0 is -1. So we will end up at 0, and because we have already calculated all these things, no need to go away. So we will simply continue from here. Okay. So from here we will simply continue. So that's why this is the logic. And okay, so everything now is calculated. All these here it is 5, here it is, what was that? I forgot. So it is 1, this 0, this 4. Okay. So everything is now all these DP is calculated as 3, this 3, this 3. And in the DFS section, what I am going to do, I will call DFS from 0. So 0 will calculate the DP of 1 first. Then DP of 5 will be already calculated. So this will become 4, this will become 5. And then all these DP are calculated. So simply DFS will execute on 4. So at 4, it will ask that what is the dB value of this? So it will be 5, so it will be 6. So now answer will be correct answer we are going to get. So this is the logic. So this complete our this solution part. And let's start from here. Okay.